Hello guys. I have observed many students have problem in solving such questions where bulbs are connected in either series or parallel, and you have to calculate these questions. So there are many confusions. So I want to solve this question, and so I decided to make a video on this. Let's start. Let's get started. Uh, the first question here in this question, the two bulbs 25 watt and 50 watt are connected in series. The rated voltage of these bulbs is 100 volt and applied voltage is 100 volt. Applied voltage means voltage of the battery, potential difference of the battery, that is also EMF of the battery. Since bulbs are connected in, one very important point here is that bulbs are connected in series. So the 100 volt, which is applied voltage, will be shared between 12 watt, 25 watt and 50 watt bulb. So for your information, neither one getting 100 volt, it is shared. However, rated voltage is 100 volt, which is the voltage to calculate the resistance of the bulb. So let's see. First part of this question is to calculate the resistance, and we know that here rated voltage. Remember, whenever you calculate the resistance, always use the rated voltage, which is 100 volt, and rated power, which is actual power of the bulb, is 25 watt and 50 watt. So the formula to calculate resistance is R is equal to VA square by P. Remember, whenever you calculate the resistance of a device, use this formula and use rated voltage and rated power. Here P. So for the 25 watt bulb, this is the potential difference is 100, means rated voltage is 100. So 100 times 100 divided by 25. 4 times, that is equal to 400 ohm. Similarly, let's say this is R1 and this is R2 for the 50 watt bulb. So in this case also the same formula is used, P1, P2, which is voltage, rated voltage is 100, common for both. This is the actual voltage on which resistance is calculated. So 50, and so it's 2 times, that will give you 200 ohm. So these are the two, these are the resistances of the 50 watt, 25 watt bulb and 50 watt bulb. Second part of the question is current passing through each resistor. So you know that since both the bulbs are connected in series, and in series we know that current remains constant, no change in current. Same amount of current passes through all the resistors because it's a single loop circuit, right? Let's see the same I which is passing, the same I passing through R1 and R2, and we know that R1 is 400 ohm and R2 is 200 ohm. And so we can find I by using the simple method of total voltage, which is 100 applied voltage divided by total resistance. Let's calculate the total resistance, which is RS series combination, R1 plus R2. Always write formula first, then substitute the values. Otherwise, in CBSE board, you may lose some marks. This is 400 ohm, this is 200 ohm, and so you get 600 ohm is the total resistance of the two bulbs in the circuit, total resistance of the circuit. Now current, by using Ohm's law, current is potential difference, total applied voltage divided by total resistance, that is equal to 100 divided by 600, and so the current is 1 by 6 amps. This is the resistance, this is the current passing through each bulb, right? They are connected in series, so same current will remain the same here, I. What is I? 1 by 6 amps. So 2 parts of the question I solved. I hope it must be clear. Now we have potential difference across each bulb. Now we know the resistance of the bulb, so things become quite easier now. So we can calculate the PD across. See here in this diagram, this is the potential difference of the bulb, 25 watt bulb, which has 400 ohm resistance, and this is the potential difference of 50 watt bulb, which has 200 ohm resistance. We know that potential difference, again using Ohm's law, potential difference is equal to current passing through the resistors times resistance. जो भी रेजिस्टेंस है इसका वो हमें लेना है, और करंट देखो कितनी करंट पास हो रही है इससे. करंट इज 1 by 6 एम्पियर. सो यूज हियर 1 by 6 इनटू रेजिस्टेंस क्या है इसका 400 ओम. दैट इज इक्वल टू 200 by 3. सो 6 times 18, 6 times 18 and 6 times 18, 67 volts. 66.67 volt is the potential difference of the first 25 watt bulb. Similarly, potential difference of the second bulb is same, current times resistance R2. इसकी करंट तो सेम ही होगी 1 by 6, resistance 200 ohm. That is equal to 100 by 3. That gives you 33.33 volts. And total is 100, 66.67, 33. So 100 volt gets divided between two bulbs, 66.67 for the 25 watt bulb and 33.33 volt for the 50 watt bulb. Oh, 50 watt bulb using less voltage because its resistance is less. Now let's see power part. That is the fourth question, is power dissipated by each bulb. The formula of power is many. They're like power is current into voltage, power is a square of current into resistance, power is square of potential difference upon resistance. We can use any, we have all the weapons, so we can use any. So P is equal to, the simplest one is V into I, right? This is for 25 watt bulb, so voltage for 25 watt bulb is 200. I always use fraction, not the decimal number, because that gives you not correct result. So 200 by 3 and current is 1 by 6. Oh, so 200 by 1 by 6 V, 200 by 3 V1. ठीक है, correct. 18 times, that is 100 by 9. That is equal to 1.11 watt. The 25 watt bulb glows dissipated, means it's 25 watt, but since connected in series and not getting 100 volts, the required amount of voltage which is rated, that's why the power delivery is less. And so P2 is again V into I, which is equal to, what is V for the second one, V1, V2. What is V2? 100 by 3 into current 6, that is equal to 100 by 18, which is equal to 50 by 9, and just half 9. 5.55 watt. See here, so 50 watt bulb, the power dissipated by 50 watt bulb is less than the power dissipated by 25 watt bulb. It means that the glow of 25 watt bulb is more as compared to 50 watt bulb. Oh wow, less power, more brightness. That's strange. So fifth part of this, heat produced, that's quite easy. Heat produced is power into time. Energy is equal to power into time. So power for the first device, 25 watt bulb, is 100 by 9. Again, use fraction to get the better result, and time, it's give 10 minutes, means 10 into 60. 3 times 2 times 20, and that is equal to 10,000 divided by 3, that is heat produced is 10,000, 3,333.33 joule is the heat energy produced by 25 watt bulb. And let's see, 50 watt bulb is P2 into T, just half, which is 50 by 9 into time, which is 600. I'm writing directly because if you calculate, hopefully you will get half of this, which is 3 times 3, 200. 200. Oh, no. Here I did calculation mistake. Here 20,000. Oh, make correction, no problem. I think 20,000. Oh my God. 6 times 18, 666 dot 6,666. This is 20,000 by 3. Yeah, 67 joule. So this is also wrong. I think got the answer. So answer 6,666.67 joule. And here you get this much, 10,000 divided by 3. Sorry for this wrong calculation. It happens, no problem. Now we have 3,333.33 joules, and so finally sixth point is that 25 watt bulb glows brighter. Yes, and that is the answer. So one learning here, that in series combination, low the power, more the brightness, and then we'll see just opposite in parallel combination in next video. Thank you.